Today we will begin Algebra 2, Unit 6. This is on quadratic functions and finding roots. This is Lesson 1, Quadratic Roots. The first half of the unit is going to concentrate on how to find all the roots of a quadratic function. There are several different methods we can use to find all the roots. The first one is by factoring. This is usually the easiest method, but the problem with factoring is it doesn't always work because sometimes we're given functions that aren't factorable. This only works for specific functions or specific types of functions. A couple things you need to know before we start. In Algebra 1, you should have learned that if you're finding roots, what you're finding is the point where your line or your quadratic, your parabola, crosses the x-axis. And a quadratic equation is going to have a power of 2. Whatever the power is, the highest power in your polynomial function is the number of roots that your function has. Since this chapter is dealing with quadratic functions, we will always have two different answers for our roots. Another name for roots, we can call them solutions, we can call them zeros, and we can call them x-intercepts. Now, hopefully you remember from Algebra 1, if something is an x-intercept, the y-coordinate of that intercept is 0. So what that means is, when we have a quadratic equation, like f of x equals the quadratic equation, what we will do is we will replace the y, or the f of x, with 0 and solve by factoring. If the function doesn't have an f of x and it's just like something like this one, where we've got x squared equals 6x, we learned that if we have a polynomial function, the first thing we have to do is get that function equal to 0 in order to factor it to solve it. So that's what we're going to do first. So roots are x-intercepts, so that means we're looking for where the function f of x is equal to 0, or where y equals 0. So in order to find the roots, we're going to set our functions equal to 0. So in order to do that here, I'm going to subtract the 6x over. And then that's a very easy factoring problem. I'm going to take out an x. That leaves me with x minus 6. And then if I set each of those factors equal to 0, I have x equals 0. I'll just put them up here. And I have x equals 6. So my two roots for that function are x equals 0 and x equals 6. And what that means is, we know it's this x squared coefficient was a 1, it's a positive 1, so we know it's a parabola going up, and we know that it will cross the x-axis at 0 and it will cross the x-axis at 6. For the next one, we've got 2x squared plus 7x equals 15. The first thing I have to do is get the 15 on the other side. I have to get the equation equal to 0. And then we've already learned how to factor functions like this. We multiply 2 times 15 is 30. We're looking for factors of 30 that subtract to give you 7. That would be 10 and 3. So I need to make a 10 and 3 with my inside and my outside term. So I'm going to use 2x and x. 2 times what gives me 10? That would be 5. 1 times what gives me 3? That would be 3. And then my signs are different. And the plus goes with the big number, the 10. So I have 2 and positive 5 and negative 3 times x. And that would give me 0 still. And then I set each of these factors equal to 0. Well, if I solve this factor, I set it equal to 0, I would have x equals 3 halves. If I solve this, set it equal to 0, I have x equals negative 5. So what that means is my graph would cross the x-axis at 3 halves, which is 1.5, and at negative 5. If we were to graph these on Desmos, you could look at those graphs and see that that's where they cross the x-axis. Here are two more equations. I'm going to set this equal to 0 and factor it. Factors of 64 that add to give you 16, 8 and 8. So we need my x and x and my 8 and 8. The plus tells me the signs are the same, and they're the same as the middle sign, so they're both minus. I'm going to set each of these equal to 0 and solve. So I've got x equals 8 and x equals 8. Now, you might be saying, I thought we had to have two answers. Well, we do. They just happen to be the same. What we call this is a double root. In a double root, what has happened is you still have a quadratic, it's still a parabola. This parabola has a positive x squared term, so a positive a, so that means it is going up, and it crosses the x-axis only at one spot. So what that means is the vertex of this parabola is at x equals 8. So anytime you have a double root, that is what the graph will do. So it gives it away. When your vertex is on the x-axis, you know automatically you had a double root right there. For the next one, I'm going to get that equal to 0, so I'm going to move the 4x to the other side. To solve that, I'm going to take the x out and set each equal to 0. Each factor equals to 0. So those are my two roots. That means for this one, it's the x squared term was positive, so it's a parabola facing up, and it will cross the x-axis at 0 and at -4. We also need to understand how to go backwards with these. In other words, what happens if I give you the roots and I ask you to come up with the quadratic equation or the polynomial equation for those roots? So let's suppose they give me the two roots and they ask me to come up with the polynomial equation that would give me those roots. Well, this is a simple thing. We're going to learn how to do this a couple different ways in this chapter. I'm just going to start with a simple working backwards method for these. The working backwards method is very simple, but you're only going to want to use these when you have real roots. If you have roots that are imaginary, or even if you have roots that have radicals in them, this method is going to be very difficult to do. It's possible with the radicals to do it this way, but it becomes very tedious and very difficult. But this is pretty easy if you have integers that you're dealing with. So if these are our two roots, doesn't that mean our two factors had been set equal to 0 to give us these numbers? So basically our roots, x equals -4 and x equals 7, when we solved those factors, gave us these two things. Well, in order to work backwards, I'm going to now take these and set each of these equal to 0. In other words, if I add the 4 over, wouldn't that give me x plus 4 equals 0? And if I subtract the 7 over, that gives me x minus 7 equals 0. Well, when we had the two factors multiplied together and set equal to 0, right? That's what we're working backwards. Now if we FOIL this, this was the original polynomial function that we would have started with. What if they have fractions? Well, if they have fractions, the first thing I'm going to do when I set them equal to x, I'm going to get rid of the fraction right here. So how do I get rid of a fraction? I just multiply by the denominator on both sides. So I'm going to multiply both sides by the 2. 2x equals 1 and x equals 5. Then I'm going to work backwards. I'm going to subtract each of those. So I've got 2x minus 1 equals 0 and x minus 5 equals 0. Then I multiply those two factors together. So I would have 2x squared minus 10x minus 1x is negative 11x. Negative 1 times negative 5 is positive 5. So that's the polynomial equation I would have started with. So here are two more. Go ahead and try to do these on your own. See if you can find the polynomial equation that would give you these two zeros or these roots. Here are those problems worked out. You can look through the work and make sure you understand where all this information came from.